Now suppose, okay, for revision let's take one question. Density of, say, hexane is 1.2 gram per ml. Okay, what is its molarity? What is its molarity? So you have to write the answer. Okay, we did this question with respect to water yesterday. Okay, so open the yesterday's PDF and then you can do it also. Yesterday's PDF that I pasted on the WhatsApp, so you can do that. Okay, see that PDF. Okay, so let's try to solve it. Okay, okay, sorry. Uh, Sorry, my screen is not shared. Okay, now it is. So this is the question. Density of hexane is this one, 1.2 gram per ml, and you have to find the molarity of hexane. Okay, this is the question. So please try to solve. Yeah. CnH2 n plus 2. So it's just C is hexane is your C6H14. That is there in the 10th class. Is that there? Organic chemistry, yes. This is your hexane. So let's solve it. Okay. Now molarity is what? Molarity is, okay, sorry. Molarity is weight upon molecular weight into 1000, okay, upon volume in ml. Okay, this one. So in 1 ml, what is the weight? 1.2 gram. Okay, that is the weight. So you can do it by various method. I'm just showing you formula based. So in 1.2, that is your 1.2 gram is in 1 ml. So in place of volume, I am just writing 1 ml, and here in place of weight, you can write 1.2 gram. Okay, so this one into 1000 upon 1, and what is the this molecular weight? So molecular weight you have to find. You can find the molecular weight C6H4. 86. Okay, so calculate it, then it is your 86. Okay, then you can do all the calculation which is required and you can get the answer. Okay. So that is your 1200. Okay, approximately 14 gram, 14 molar, sorry, that would be the answer. So in this way you can do that, or you can just find in 1000 ml what is the weight, then you can find the number of moles, so that also can be there. Okay, suppose in another method, that is your 1.2 gram. So in 1000 ml, because you have to take 1000 ml means 1 liter should be there, so it will be 1200 gram. 1200 gram means how many moles you have to take, so 1200 divided by 86, so that will again be equal to approximately equal to 14. So that is basically those, these two are same method, but formula based approach is you can use in exam, that is typically fast. Here also, if you have these all the concept clear, you can use this one also. Okay, so that is one more question. Now another concept which we have to learn today is your molarity of mixing. Molarity of mixing of two solutions. Molarity of mixing of two solutions, so that is another concept here. So last time we learned about concentration and dilution, so here molarity of mixing. Now these two solution should not be reacting, means they should be unreactive. Unreactive means they should not react with each other. Okay, that this is the condition. So I will tell you which one will react, which one will not react. So typically we are taking only unreactive solutions. Now let's do this. Suppose we take two solutions. Okay, we take let's say 0.1 molar 100 ml glucose, and it is mixed with okay, 0.5 molar 25 ml glucose. So both are glucose solution. So glucose will not react. Okay. Now new molarity you have to find. Okay. Find the new molarity. New molarity of mixture. Okay. So here, what is the new molarity? New molarity you have to find. It means you have to find the total number of moles and total volume you have to find. Okay. So new molarity is your number of moles of first solution. This is number of moles of first solution plus number of moles of second solution into 1000 plus volume of first solution plus volume of second solution, and volume are in ml. So this is one formula. This you can use, number of moles you can find, and then you can put the value. Then another formula is this m1 v1 plus m2 v2, okay, divided by v1 plus v2 is equal to m v. This is another formula. Okay, these are the two formula. Both are easy. Okay, but this one is slightly more easier than first one because you have to calculate the number of moles. So this you can do. Okay, here calculation is easy, here calculation is typical, so just you can take that. Okay, so it should not be there. Okay, so this is two formulas are there. Okay, you can use either of them to calculate. Suppose we are using this one. Okay, we are using this one. Now what is m1 here? M1 is this molarity 0.1. Okay, so this is m1. M1 is 0.1. V1 is 100, so write 100. plus m2. M2 is 0.5 into 25 is your V2 divided by 100 plus 25, and that will be m. So you can calculate this one. So that will become 10 plus 25 5 is 125, so it will be 12.5 divided by 125. Okay, so that will become, okay, so that will be 32.5 divided by 125. So here you can calculate this one. Okay, so I don't think there is any problem if you are not getting. Yes, yes. Number of moles, these are number of moles. Number of moles of first solution, this solution, and number of moles of second solution, this solution. V1, V2, V1 is 100, V2 is this one. Okay, so this will come as 0.26, 0.26 molar. That is your M new molarity. This is the same thing. Okay, so same thing will come from this method. Okay, this method. So both have their own importance. Both have their own importance. You can use either of them. Okay, depends upon the student to student. Okay, whatever you want, you can use. So this is okay. This is for unreactive. They should they are not reacting. Okay, this one. Okay, so let's do one question for this. Okay, all of you are getting this. This is just the formula, and you have to just put the values. So now let's take a question for this one. Okay. Find the new molarity when 0.5 500 ml 0.5 molar 500 ml NaCl solution is mixed with 0.1 molar 2000 ml NaCl solution. Okay, so this is the typical question. You can, that is easy one. Okay, just find it. Okay, find the answer. 2000. Okay, so everybody, I think everybody can answer it now. okay, 0.18. So that is your typical answer. So let's take a, I think that's correct. I think. So 0.1 into 2000 on 2000 plus 500. Okay, so this is, so let's solve it. So it will be 250 plus 200 upon 2500. So that will be 450 upon 2500. Yes, I think that is 25 to the 50. So that is not there. Yeah, approximately it is correct. Yeah, so that is your 0.18 molar. So that is your new molarity. So that is your molarity of mixing. Okay, molarity of mixing. So that is most of the time they ask this question. You will see this question in equilibrium, the chapter. I think that is your first, second, third, fourth chapter of the physical chemistry. So that is there. So you will use huge amount of this problem. Now, okay. So this is one of the, that is your easy task. Now, uh, another concept is, if acid and base are mixed. Okay, if acid and base are mixed, okay, then this m1 v1 and m2 v2 divided by v1 plus v2, this formula we don't use. Okay, if acid and base are mixed, so we use this formula. Okay, f1 m1 v1 plus f2 m2 v2, okay, divided by, oh sorry, I have to, v1 plus v2, and here it is subtraction. Okay, and this is the mod value. Mod is your that it will not come in negative. Okay, whatever is there, so that is a mod value. It is your mod value, it should not come in negatives, and that is your md. Okay, now everything you know except this f. Okay, now f is number of OH ion or H plus ion given by 1 mole acid or base. Right, base or acid, base or acid. So that is the typical thing you have to see here. Okay, so I told you this in the, when I told you the equivalent weight. Okay, so during that I told you that for HCl has 1 proton, so for HCl it is F is equal to 1. For H2SO4, F is equal to 2 because here 2 protons. Okay, for H3PO4, here it is F is equal to 3, it can release 3 proton. For base NaOH, only 1, so F is equal to 1. For calcium hydroxide, F is equal to 2 because there are 2 OH ions. Okay, 2 OH ions, so F is equal to 2, and F is equal to 1. That is for 1 OH ion. Okay, this is also, yes, yes. So when acid and base are mixed, okay, when acid and base are mixed, so we use this formula. Okay, this one, F m1 v1 minus f2 m2 v2 v1 plus v2. So that is your new molarity. Okay, mod value is there. Now this is how to solve it? Let's see. Okay, only you have to remember this. Okay, suppose HNO3 I forget, so HNO3 F is equal to 1. So these are the typical acid which will come. Okay, but you will learn eventually when you will study inorganic, so you will learn 20-30 acids. Okay. Now should I start? Okay. Now let's take example. Let's take example. So let's take 3 molar 0.1 molar HCl, okay, is mixed with 2 molar 0.1 molar of what I am writing here. Sorry, 3 molar. Let's take 100 ml HCl. Let's take 200 ml calcium hydroxide. Okay, then you have to find the molarity. What is m nu? So new molarity you have to find. So we have to solve this in the normal manner what we have done, okay, till now. So 3 is for HCl, so take the mod value. We are taking the mod value. Now F for HCl is 1, so we are taking 1. 3 into 100 minus F factor for calcium hydroxide is 2, so let's take 2 into 2 into 200, so that is for calcium hydroxide, and this is for your HCl. F factor for this is F is your 1 here and F is 2 here, so this is okay. Now divided by 100 plus 200, so that will become 300. Okay, so that is your angle. So just calculate it and then you can answer. So here it will be 300 minus 2 to the 4, and that will be 800 divided by 300. So that is in the mod, and that will come as minus 500 by 3, so that will be 5 by 3. Okay, so that is typically okay, so that will be 1.515 to the 45, so approximately that one. Okay, so this is the well around that one. So that is not exactly 1.5, approximately. So any doubt in this? Any doubt? Okay, so that is only for acid plus base. Okay, acid plus base. Suppose they mix acid and acid, then you don't have to do this thing. Base plus base, you don't have to do this thing. Okay, just write for this is for only acid and acid plus base. Okay, if HNO3 and HCl are mixed, you have to use that the previous formula M1V1 plus M2V2 divided by V1 plus. Okay, so this formula is used when they are reacting. Most of the time that is acid and base which are reacting, or there is a reducing and oxidizing agent, reduction and oxidation are going on, so there some reaction is going on. So here at that time we will use the formula, but at first in the first chapter they will just give you this one, so I don't think that they will ask you for something more. Okay, this formula we will again use in ionic equilibrium. This formula we will use there. Okay, so I hope so you got this one, molarity. Okay, then next concept. Okay, so molarity we have done. Okay, so molarity we have done, so I'm just writing all the formula for molarity so that it will be easier for you. For what? Previous formula. Huh. This one you have to use. Hello. This formula you have to use for acid plus acid. Sorry. If it is acid plus acid, base plus base, okay, or same type of means solution, okay, glucose or glucose, something like that, so there you can use that one. Okay, okay, have you done it? So this is the typical one. There is a typical formula, means it's not a formula, it is just your number of moles divided by volume. So okay, so just we have completed the molarity, so just I'm writing all the formulas. So molarity is your number of moles into 1000 upon volume in ml. It can also be written as weight upon molecular weight into 1000 upon volume in ml. Okay, then there is concentration and dilution. For dilution you can use m1 v1 is equal to m2 v2. So v2 is here v1 plus some extra volume xml for dilution. For concentration it is m1 v1 is equal to m2 v2, but here v2 is v1 minus some xml. Okay, so that we did yesterday. And for this mixing we have just done. Mixing is your m1 v1 plus m2 v2 upon v1 plus v2. So we can take it m nu, or for acid and base m1 v1 minus m2 v2 divided by v1 plus v2, that is in the mod, that is your n. So basically these are the four formulas which are there, okay, to solve all the question of molarity. Okay, this is the most basic formula. This one, n is your number of moles. Now always remember, sometimes they give you one solute and one solvent, sometimes they give you many, okay, solute and one solvent. Okay, so I just want to give you example. Okay. Suppose the question is like this: in a 100 ml, okay, it's not, in 100 ml water, okay, 5.85 gram NaCl, okay, 6 gram urea, and 1.8 gram glucose is dissolved. Okay, what is the molarity? Okay, so in this type of questions, if there are more than one solute, so you have to calculate the moles of each and every solute, then add all the moles and then put it in the formula. Are you getting it? You have to calculate moles of NaCl, moles of urea, and moles of glucose, and then you have to put it in the formula. Suppose let's solve it, okay, then you can understand it better. So molarity is your number of moles of NaCl plus number of moles of glucose plus number of moles of urea into 1000 upon volume in ml. So this you can do. Okay, so number of moles of NaCl, how will you calculate? Weight of NaCl 5.85 divided by molecular weight. Molecular weight of NaCl is 58.5. This is a molecular weight. Okay, so 5.85 is the weight and 5.58.5 is the NaCl weight. Now weight of glucose is given as 1.8 grams. Now glucose molecular weight is 180. Okay, then it is urea. So urea is 6 gram, that is given, and molecular weight of urea is 60. 60 is the molecular weight of urea. So this, so moles of NaCl is this, moles of glucose is this, moles of urea is this into 1000. Now volume which is given is 100 ml here, 100 ml. So that is your 100 ml. Okay. Now we can calculate all this. So this is how much? 5.8 and 50 this one. So that will be around zero point 0.1. Okay. This is your zero point 0.1. Okay, and it is, then it is your 1 and this is your 100, so that will be 0 0.1. Okay, then it is 6 by 60, again it is 0 0.1. Okay, into, that is your 1000 by 100, so that is your 10. So that is typically, that is very easy problem. So it is 0 0.1, 0.1, 0.2, and that is your this 0.1, so that will be 0.21 into 10, so that is your 2.1 molar. Okay, 2.1. So in that manner you can also do this. Yeah, yeah, yeah. Yes, yes. Okay, now I am moving. Yeah, I hope, have you done? Are you done with it? Okay. Okay. Now, okay. Now, one thing that I left for the molarity is your molarity of liquid plus liquid solution. Molarity of liquid plus liquid solution. Okay. Now, in liquid plus liquid, suppose you take water plus ethanol. Okay, water plus ethanol. Okay, so in the this ethanol is normally I'm just taking 99.99% pure ethanol. Okay, ethanol is there in the wine and beer and all these drinks. So here I'm taking water plus 100% ethanol, pure ethanol I'm taking, and pure water. Now what happens if I'm taking uh, whatever is the smaller amount in ml, that will be solute. Whatever is the larger amount in ml, that will be your solvent. Suppose here I am taking 10 ml water plus 90 ml ethanol, and that is total 100 ml. Okay, so here it will be solvent, it will be solute. Okay, now if it opposite happens, suppose I am taking 80 ml water and 20 ml ethanol, so here it will be solute and it will be solvent. it is also 100 ml. Okay, this one. Now if these are the two situations, now if you have to find the molarity of this one, this solution. Okay, so molarity, for molarity you have to find the moles. Now always find the moles of solute, whichever is less is solute. So you have to find the moles of solute, that is your water in this case, first case, that is your first case, second case. So 100 ml is your this. So 10 by 18, that is your moles of water into 1000 upon volume. Here we have to place the volume. Now which volume we have to place, 10 or 90 or 100? So we have to place the total volume of solute plus solvent. Okay, so here I am putting 100. So this is the molarity of this solution. Similarly, if here 80 ml is solvent, 20 ml is there this solute. Okay, so here ethanol is solute, so I have to calculate the ethanol moles. So that is weight of, okay, this one. uh, okay, this, so okay, I forgot to give the density. Let's, okay, so density of ethanol, okay, C2H5OH is ethanol, is around 0.8 gram per ml. Okay, that is your density. Okay, so this is your density, and mass is equal to mass or weight, you can take density into volume, because density is your mass upon volume. So mass is equal to density upon volume. Now you see this one, we have not considered density here, because density is 1. So 10 ml means 10 gram water. So no problem here. You just put 10. Whatever is the ml in water, you can just put it as equal to weight, because density is 1 for water. If the density is not 1, greater than 1 or lesser than 1, then you have to take density into consideration. Then mass, because we have to put here mass is density into volume. So whatever is the density, that is your 0.8. Okay, 0.8 into, okay, volume is 20, so multiplied by 20 divided by the molecular weight. Okay, molecular weight, so molecular weight you can calculate 24, that is a 24, that is a 46, it will come as 46. Okay, into 1000 upon total volume, that is your 100 ml. Okay, so this is how to calculate the density. If you have any doubt, please ask. Please ask your doubt. Okay, see, 10 ml, from where your network gone? The second case. Okay, so in second case, solute is your ethanol. Ethanol is the solute. Okay, so its density is your 0.8 gram per ml. I forgot to give you density. 0.8 gram per ml, that's the density. So what is the mass of ethanol which is there? So mass is density into volume. So density is the into volume is the mass divided by the molecular weight. This is the molecular weight of ethanol, 46. 1000 divided by 100. 100 is the total volume. Okay, total volume. So this is your 100. So that's how we can calculate. For water, okay, I have not multiplied into volume density. The density volume not multiplied, because density is 1. So whatever is volume, that will come as the weight. So this is the answer. Any other doubt? Okay. So this is for the volume plus volume. Or, sorry, that's liquid liquid solutions which are there. Okay. Now, if two volumes are equal, okay, two volumes are equal, 50 ml ethanol plus 50 ml water. Now, here both are 50-50, so how will you consider whichever is your solute? Okay, whichever is your solute, 50 ml this, 50 ml this. So solute solvent concept will not be there. Okay, here. So we have to calculate molarity by taking ethanol as a solvent, and we have to calculate the molarity by taking water as a solvent. Okay, and we have to mention it. We have taken volume of water. We have taken water as a solvent. So there, after the calculation of the density, there is a line you have to write. We have taken water as a solvent. Okay, or we have taken ethanol as a solvent. Whatever solvent you are taking or solute, you have to mention it. So in this case, there is no definition given by IUPAC how to calculate the molarity, which molecule you have to consider as solvent or solute. So there you have to mention. In the paper they don't ask such questions, but for your information I told you. So you have to mention which is solvent and solute. That only thing you have to mention after calculation. You can calculate on your own way, no problem. Okay, so this is about the molarity. Now let's take another important one, is your mole fraction. Mole fraction. Okay. Now what is mole fraction? Mole fraction is your basically, we can let's there is no definition, but if I write, if there is a mixture, there is a mixture of three uh, three solutes plus one solvent. Okay, so okay, three solute plus one solvent. Suppose 1 mole NaCl plus 2 mole your glucose. Okay, plus 4 mole, not take 4 mole, let's take 3 mole. 3 mole take urea. Okay, in 4 mole water. In 4 mole water. Suppose this is solution. Okay, I have not taken the volume of the water, just took the moles, because moles are ultimately which is required for the mole fraction. So 1 mole NaCl, 2 mole glucose, 3 mole urea in 4 mole water. Okay, 4 mole water you can multiply, it's 18 for the 54, so that will be 54 ml, but I am not going into that. Now what is a mole fraction? So there is individual mole fraction. So mole fraction of, let's take glucose, mole fraction of glucose. So here it will be moles of glucose divided by total moles. Total moles. So moles of glucose are how many? 2 moles divided by all the moles. 1 plus 2 plus 3. So that will be 6 plus 4, 10. So 2 by 10. So that will be 0.2. So 0.2 is the mole fraction of glucose. Okay. Are you getting it? So we have added all the moles, that is your total moles, and these moles of glucose are divided by the total moles. So that is a mole fraction of glucose. So that is only the mole fraction. Suppose if someone asks mole fraction of water, okay, mole fraction of water. Okay, so what are the moles of water? That is your force. Total moles will always remain 10, so that is your 10. So that is your 0. Sorry, one minute. I'm just scrolling. Okay, so this one. So 4. Okay, so that is your mole fraction of glucose. If you're talking about the mole fraction of glucose, then your moles of glucose divided by the total moles. Total moles, I told you how to count: 1 mole, 2 mole, 3 mole, and 4 mole. So that is your total moles. Whatever are there in the solution, that is your total moles. Whatever moles are there in the solution, that is your total moles. Okay, so there is each and every molecule, NaCl or glucose or urea or water, will have their own mole fractions. Okay, there is individual mole fraction. What I told you, individual mole fraction. So glucose will have its own mole fraction, water will have its own mole fraction. Similarly, NaCl will have its own mole fraction, urea will have its own mole fraction. Okay, have you understood that one? Is there any doubt? Okay, now if I say mole fraction of NaCl, only 2 mole fraction are there. Mole fraction of NaCl, so that will be 1 by 10, so that will 0.1. Okay, and mole fraction of urea, so urea has how many moles? 3 moles, so 3 by 10, so that will be 0.3. Now you see this mole fraction, uh, mole fraction of glucose is 2, mole fraction of water is 4, and it's zero point 0.1 for NaCl, and for urea it is 0.6. So if you add all the mole fraction, 0.2, 0.4, 0.1, 0.3, if you add all the mole fractions, okay, so what you will get? You will get 1. 0.2 plus 0.4, that is your zero point 0.6, and here it is 0.1, so 0.7, 0.7 plus zero point 0.3, it is 1. So when we add all the mole fraction, okay, that will lead to 1. So we can again we can write that summation of all mole fractions is equal to 1. Okay, so because that is just 0 0.1 for NaCl, 0.3 for urea, plus 0.2 for glucose, plus 0.4 for water. So that will lead to your 1. So whatever we will add, that will give us. Okay, so in any, it is always 1. If you take anything, it is always 1. Suppose, okay, okay, should I scroll up? Okay, so this is okay. So that is your the summation of all the mole fractions. I should write mole fractions. Mole fractions is always 1. Okay, suppose you take okay, suppose we take 3 gram urea plus 9 gram glucose. Okay, so only this we are taking. Okay, So here if we want to find the mole fraction of say glucose, so what is the mole fraction of glucose? So first you have to find the total moles, then you have to then you have to do all this calculation. So what is let's just find first this moles of urea. So what are the moles of urea? Moles of urea, it is your 3 by 60. So 3 by 60, 60 is the molecular weight of urea. Okay, so it will be 1 by 20 or 0.05. Okay, then moles of glucose. Okay, so it will be 9 by 180. Okay, so again it will be how much? 0.05. So this is your mole fraction, oh sorry, moles of glucose and moles of urea. Now urea mole fraction of urea is how much? That is your moles of urea 0.05 divided by 0.05 plus 0.05. That is your moles of glucose plus moles of urea. So that is your total moles, and this is your moles of urea. So that will come as 1 by. Similarly, mole fraction of glucose, so that will come same, 0.05 divided by 0.05 plus 0.05. So again it will come as 1 by 2. Now if you add, now summation of the mole fraction will be summation of mole fractions. So what you will get is your 1. So 1 by 2 plus 1 by 2 is your 1. So always and always your summation of mole fraction, that is 1 by 2 1 by 2, you will always get. Okay, so that is your this one. So urea is this much mole fraction of glucose is this much. So summation of mole fraction is always equal to 1. Okay, so that is the, you can say, uh, definition or a line on the stone. So that is always equal to 1. That will not change. Okay, have you understood this one? So that is your mole fraction. That is your mole fraction. So this is one of the concept, but not too many question will be asked on this one. Okay. So they don't ask too many questions. There is application in the solution in the 12th class, yeah, when you will study the solution chapter. Okay, so a lot of application are there in, and in chemical equilibrium there is a lot of applications. Okay, so now let's take another concept, that is your molality. Molality. Okay. So previous one was molarity. It was molarity, and it is molality. So small pronunciation error can create some mistake. So that is a molality. Okay. Now what is molality? Oh, sorry. Molality is definition is slightly same. Okay. That is your number of moles of solute. Okay. Dissolved in 1000 gram of solvent. Okay. Here solvent weight is 1000 gram. Okay. Only you have to take only the weight of solvent, not the weight of total this solution. You have to only take the weight of solvent. So that is your molality. Wait for 1 minute. I'm just coming. Okay, now let's start one. So number of moles of solute dissolved in 1000 gram of solid. 1000 gram means 1 kg. Sometimes there are you can write 1 kg also. So 1 kg can be there. Okay. Now why do we want this? Because both are approximately same, but the weight is taken here. Okay. So molality is used when temperature is fluctuating. When temperature is fluctuating. Okay. So what happens with the volume? Suppose we take molarity. So in molarity, we use 1000 ml of solution. Number of moles of solute dissolved in 1000 ml of solution. So volume, when the temperature is changing on a regular basis, not on a regular basis, but suddenly there is a change in temperature, volume changes. Okay, when increase the temperature, volume of gas or any liquid increases. When we decrease the temperature, volume decreases. Okay, so if we fluctuating, I should write it clearly. It's not visible. Okay. So, no, we can also find it. Weight is always there. No? Everything has weight. I'm just trying to give you a glimpse of importance why it is used. Okay. Why molarity is not used. So when temperature is changing, molarity is not used, because if the temperature is changing, volume will change. So at some temperature, volume will be okay something, and at the higher temperature, volume will increase. So molarity will change, because molarity is dependent on temperature. But if we take molality, then it will not change, because weight doesn't change with the temperature. If it's 0 degree or 100 degree, whatever is the temperature, weight will not change. Okay, weight will not change, only volume changes. So this molality has importance when there is a change in temperature. Okay, temperature changes due to some reaction, or there is external temperature change suddenly. Okay, in the morning we have some other temperature, and then in the afternoon the temperature increases. So there is a slight change in the temperature. This slight change is very important when we are doing the biochemical reactions, because in biochemical reactions, very smaller amount is there, 10 to the power minus 12 grams, 10 to the power minus 8 grams. So and the volume is 1 ml or something like that. So if volume changes slightly, then there is a huge change in the molarity. So we don't want that, so that's why we use molality. So that is the importance of molality. Molality do not changes with the change in temperature. One thing should write: molality do not change with change in temperature. Okay, this is the importance there. So this is okay. So this calculation is also very easy. So let's take the formula. Okay, it is denoted by small m. Small m is your molality, capital M is the molarity. Number of moles of solute, that is your moles of solute, into 1000 upon weight of solvent in grams. Weight of solvent in grams. So that is your formula. And for number of moles, we can write weight, which is given to us, divided by the molecular weight, into 1000 upon weight of solvent in grams. So this is the formula which is there. Okay, have you understood this one? So this is the typical formula for this one. This is the typical formula. Okay, normal formula, whatever is there in the definition, that is in the formula. Okay, okay, this one. Now, there is a relation between. Okay, let's don't go for relation. Just do one two question, then we will go with the relation with the density and all that. So let's do some question for understanding. Mm, okay, so this is the question. Okay, then molecular weight of urea is 60 grams. Okay, this is a question. Quickly find its answer. Yes, Aparajita, what is the answer? Yes, correct. Okay, let's solve it. So molality. Okay, so here 3 gram of urea is there, so that is your solute, and weight of solvent is how much? So here weight of solvent, because solution weight is equal to weight of solvent plus weight of solute. Okay, that is your this general thing. So weight of solution is how much? 203 gram. Weight of solvent is x. Solvent is your water, and weight of solute is 3 gram, that is your urea. So water is your 200 grams. Okay. Now finding the molality. 3 gram is the weight, 60 and 1000 by 200. 200 is your water. Okay. 3 gram is your urea. Okay. This one. So you can calculate. So that will come as 0.24. Okay. Are you getting it, everybody? Mm. So solvent, weight of solvent you have to take, not the total weight. Okay. In molarity, you have to take the total volume of solution. Okay. In molality, only solvent weight is required. Okay, only solvent weight is required. Okay. Then I'm just giving you another question. In ethanol, okay, with the density of 0.8 gram per ml. Okay. Okay, 4 gram urea is dissolved. Okay, volume of C2H5OH is 50 ml. What is molality? Okay, what is molality? Yes, teeth. Are you doing? Okay. Ah, yes, Aparajita. Harsh 2.10. Now let's 2.178 5s of 40 460. How we are getting 2.17? So let's solve it. Okay. So what is the weight of solvent? Weight of solvent is your density into volume. So that is your zero point 0.8, volume is 50. So that is your 40 gram ethanol. Okay. So molality is equal to, so 4 gram urea. So that is your weight divided by the molecular weight of urea. Molecular weight of urea is 60 into 1000 divided by the 40 gram ethanol. Okay. So this cancels out. I should not do this one. Okay, then you can calculate this. Okay, so that will be zeros and zeros, and that will be 6 by 10, 10 by 6, sorry. So it will be 1.66. Aparajita, how you are getting 2.1? Okay, okay, you took the molecular weight. Okay, no problem, no problem. Okay, no problem. Anybody having any doubt, please ask your doubt. Okay, no doubt. Okay, so we are closing in here today. Okay, please try to do molarity problems and the concentration terms. Tomorrow we will continue with the molality, normality, percentage. Okay, so tomorrow I will try to finish it. Okay, so we will start at 4 and continue. So today is what, Wednesday? Okay, Wednesday, Thursday, up to Friday maximum. it will be over. If some if it is required, I will complete this on Saturday if it is there, but I think it will be completed on Friday. uh, I will talk to Patelish is not coming here. What happened to him? Okay, so we are closing. You can leave the meeting. I will upload this PDF.